A very good afternoon to one and all present here. I hope I'm audible and visible. Can you all hear me and see me? Great to see you all back. How's everyone? Awesome, awesome, awesome. I'm doing great. Thank you. Thank you for asking. Great, 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 great to hear that. Uh, okay. How's everything with respect to the classes? Is SQL over or is it still going? Or have you been moved to some other module? It's continue. Doing case study. Awesome, awesome. Great to hear that. Good, good, good. Okay. Great, 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 great to hear that. Hmm. So any information that what is the next module that you're going to start with? Or you have been informed about the next module or you are still unknown? No idea. Hmm. Okay, maybe probably in the next class you'll get an idea on which module you will be uh, thrown into. Yeah, great. So I'll try to finish the things we have left in the previous class. Not sure that whether we are going to have this as our last class because a few important topics are left and I do not want to rush on those topics. Those topics are equally important. So we'll finish those topics. Having said that, we were doing some case studies on pandas, if I remember. Yes or no? I have given you a case study on a Netflix case study, Netflix data. And I've asked you that, do the analysis on this case study. So today, our motive is to complete this case study. Along with this case study, we have two more case studies. Okay, two more case studies. Let me see how it comes. But yeah, two more case studies so that we have a equal better hand on pandas as well as on two new libraries that is matplotlib and seaborn. So my target is to complete this matplotlib, seaborn and pandas today. We are again left with some things that we have left in Python, that is oops principle and some of the library functions like lambda, apply, or zip functions. So we'll understand and sets and dictionaries. So that leftover part, probably we'll have one more class to cover all the leftover content. But again, our idea is simple that we want to get perfect on this pandas part. And then as soon as you cover this pandas part, with respect to the case studies, then we can move to the some emergency. I didn't attend the last three classes. So no worries, Kitna. I would advise you that please revisit the last three classes because every class is interlinked with the next topic. So I would advise you that if you have not gone through those classes, please go through them. You'll have a complete idea that how the content has been covered. Okay. So yeah, pandas, matplotlib one that we are trying to cover in today's class. Okay, so that we can cover this on a comprehensive basis. Um, have you all got the notes of the previous class? Yes or no? Have you all got the notes of previous class? And I've given an assignment that solve this Netflix data on your own. How many of you have tried an attempt to solve this Netflix case study? Answer me yes if you have tried to solve this Netflix case study. It does not matter whether you have solved it fully or not. At least you have tried. Good, good, good. See, people, if you are coming to the classes and if you're not solving these case studies, okay, you will not get benefit from it. Let me be brutally honest, because there are number of tons of functions in pandas or numpy. No one can remember all those functions, but case studies are a medium through which we can remember those functions. That's why I say that do these case studies, practice these case studies, and see how these functions are used in the a real life perspective, so that you get a comprehensive idea that this function that we have studied is used in this way in this case study. So it's very important that you learn the concept through case studies, that then you'll get a holistic idea. If you're simply learning the functions, and if you're not known you're not knowing that where what is the real application of those functions, then there is no use of studying tons of functions, not required, and you'll get confused eventually in the interviews. That's why these case studies are very important. And if anyone has not solved it, obviously, I can see most of the people have solved it. But some people who have not solved it, please go through it. Okay, please solve it at your end. Today, I will present the solution of it, that how I have attempted to solve it. Okay, go through the solution. I'll provide a solution to you as well as as a what do you say, as the notes part. So I'll give you the solution of this Netflix case study. Apart from this case study, we will do certain more functions on this Netflix case study, some more functions on pandas on Netflix case study, so that we can get a holistic idea that, yeah, these functions would also be utilized and can be leveraged in this Netflix case study. Apart from this, we'll study a case study on Pfizer medicine. So probably we'll jump onto this topic as well. Along with this, we'll study something about EDA, exploratory data analysis, which is very important in Python. And if you are preparing for data analyst roles, you should be well aware of about this concept. Again, telling that I will not be in a hurry to complete all those concepts. You will see that how quickly we progress through those topics. And if it takes time, not an issue for me. I'll take one more class to finish the whole course, but we will not make a hurry, because these things are very important. And you can expect questions. You can expect you all your project making, all your what do you say, case study making, all would be done from these the last two classes. So I'll not take a hurry to submit to clear all those concepts. Once we are clear with each and every topic, then only we can move to the further content. Is everyone getting a clarity that how we are going to proceed forward? Can I get a quick yes from all of you? Awesome, awesome, awesome. Okay, I want my class to be full enthusiastic, because now we are going to study the solution of the case study, that is Netflix case study. Ask me if you have any doubts. Okay, we'll solve that doubt instantly, and we'll move forward. Okay, just give me a second. Hmm. So I'll explain this. I'll not run the code, because that will take time to write and run. I'll just explain this case tree through these notes. Okay. I want complete attention on my notebook. So please leave everything. Please focus on my notebook. So I have given you two files, two IMDb files. If I showcase you these two IMDb files, one was, I guess, this one, which was our movies.csv, and the other file was this file, directors.csv. Is everyone having these two files? Is everyone having access to these two files? First, tell me that. I've shared these files in the previous class, also in the notes part. So I hope everyone has these two files available with them. Yeah. Now, if we look, could you please reshare the same? I'll reshare. I'll reshare. Not an issue. I'll reshare the whole case study part. Okay. Then let's first see this data. Okay. If I want to I want all of you to see this data. So what I've done. Let me run this. It is a IMDb movies dataset, okay? And you imagine you are working as a data scientist or a data analyst at an analytics firm, and your task is to analyze the movie trends for a client. IMDb, as I told you, that it is a online platform where you see the database of all the movies. Here, I have given you two files. Okay, the first file is of movies file, and second file is of directors file. Okay, let me run it. So if we run this, okay. Mm. So if we run this, movies is equal to pd.read.csv. This is the command that we use to run to read a CSV file. I hope everyone is aware of this command. And if you see this command briefly, okay. So what you see, there's an unnamed column which is 0, 1, 2, 3, 4. What does it tell me? It means that there is a column which is present in my dataset which consists of, what do you say, serial numbers. So if you go here, can you all see a column unnamed, a blank column here, which number 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, a serial number? Can you all see this? See, I want my class to be enthusiastic. So please be responsive in the chat box so that I know that whether you are understanding the fact or not. Okay. So everyone can see that there is a unnamed column, and this is the column that basically stands for serial numbers. Okay. And if you have written movies dot head, what we can see a unnamed column with serial numbers here. We will see that whether this column is useful for me or not. Let's leave this column as it is. Then we see a second column called as ID. Now this ID basically means the ID of the movie. So what is the movie ID? Obviously, this has to be unique for every movie, and you see this is the movie's ID for with respect to each and every movie. Then there's budget for each and every movie, which is described here. Now units are not described here, but I'm assuming that it is in millions or crores. Let's leave it. Leave the unit to yourself. Okay, you all decide. Let's not focus on the unit for a while. Budget is somewhere which is given in this format, and you can see the budget with respect to each movies. Then there's a popularity. That what is a popularity? It could be that how many people are interested in those movies, or how many people like those movies. So that could be the popularity score. I'm not sure about that. That how IMDb treats this is data that is directly taken from the IMDb side. So popularity, I am assuming that this could be the how many people like this. Like if you go to Amazon Prime, okay, sorry, Prime Video, or you go to any Netflix, you see that 3.2K people like this, 1.2K people like this. If you see a movie banner, similarly could be seen with this metric, that is popularity, 150, 139, 107. This could be an opinion that how many people have liked this movie. Okay. Then there's revenue. How much was spent, or what was the revenue for each and every movie that is represented here. Then we have a title. What is the movie name? So you can see the movie name: Avatar, Pirates of Caribbean, Spectre, Dark Knight Rises, Spider-Man, all these things. Then there's vote average. It means that what was the average voting for that particular movie based on all the users. So this could be a number of likeness divided by total number of people, or number of likes divided by total number of likes plus dislikes. Any metric that IMDb has suggested. But yeah, vote average is just generally that is what is the average voting, that how many people have liked this movie. So that could be the vote average. Then vote count. It means that how many people have voted for this movie. How many people has actually voted. Does not matter that they have voted in the positive direction or negative direction, but they have voted for this movie. That is 11,800 people have voted, and similarly could be seen for the other movies as well. Then we have a unique ID with respect to each and every director. You can see 4762, 4763. It means that which director has directed that movie. The director's special unique director ID can be seen here. Then we can see year, on which year that movie was released. So we can see the production year of that movie. Then we see that month, on which month we can see we had seen the release of that movie. So that typically tells us the month, and day. What was the day when that movie was released? Is everyone clear about the data set? Movies.head. Is everyone clear about the data set? Doubt how we have clear so that we can move forward. Great. Now, some questions that you could have asked from seeing this movies.csv, some questions you could have answered. Top 10 most popular movies using popularity. I can give, hey, what are the most popular 10 movies that I can get from this data? I can even find the highest rated movies using the vote average. I can find the highest rated movies using vote average. I can find even that as well. I can find the number of movies released per year. So to get an idea that how many movies are released each year, I can get that an idea as well. I can even find the highest budget movie in a year using both budget and year. Let's say we have year at one. Let's say uh, I have year at one column and budget at one column. What I can find? Hey, let's say in the year 2016, the highest budget. Okay, the highest budget movie and the movie name. I can give certain information to the client so that he get an idea that in 2016 the highest budgeted movie was Avatar with the Avatar with a budget of like this. So we can get those information from that data. So I hope the data analysis part of this movie is clear to everyone. Okay. Now, if we move to some interesting questions, these are very basic questions. Okay, everyone can answer this even if he's not a data analyst, he can answer this. Yeah, I can think of those questions. But since you are preparing for this data analyst role, how you have to think? Now, you can think that you can find the most productive directors. How you can find the most productive directors? You can basically find the most productive directors by basically looking on the fact that a most productive director is the director who might have, okay, who might have directed, who might have directed the most movies in a particular time span. Now see how important is this. Now if I say that there is a director A, okay, director who might have directed the most movies in a particular time span, okay. Now let me give you two examples. Let's say there's a director A who has directed 100 movies, okay, and there's a director B who has directed, let's say, 80 movies. But this director has directed these 100 movies in a time span of 2010 to 2015. Let's say, just giving a blank example. And this director has directed this 80 movies in a time span of 2015 to 2018. Whom do you find as the most active director or most productive director? What do you think? What do you think that which director must be most productive or active? Everyone would suggest that, hey, director B is more productive. So what we get an information from here, that when we are looking for the most active director or for the most productive director, we are not looking on the simple fact that the number of movies he has produced. We are looking at how many movies he has produced in the recent years, or what was the gap, that what was the minimum gap. So as close as the minimum gap, and as high frequency, as many movies he has produced in that gap year, in that gap, more active is the director. So we can frame we can frame a metric like that. Hey, if I want to give the top 5 most active directors in this era, I can give them their names, right? So yeah, in this case, B would be a high productive director as compared to A. But if I compare the total movies, obviously A will rule it. But I don't want the person with the director with the highest number of directed movies. Maybe this director is dead. Maybe this director has left directing the movies. This could happen. So to get a good idea that who is the most active director, I would look into the not only on the movies part but also on the time frame part. Is this clear to everyone? This is how you have to think, that this could be the most active director because this person has directed the most number of movies in very less time span, in the range of time span where it is very less. So we can get those information as well. Okay. How we'll get that? That is a different thing. But yeah, we can frame the metric like that. Great. Then let's move ahead. Which directors produce the highest budget films? So we can get that information as well. Huh? Which director has the high budget films? So we can get an idea that if it is a low budget film, I can recommend it to this director. If it is a medium budget film, I can recommend to these chunk of directors. If it's a high budget film, I can recommend to these chunk of directors. So that is an analysis that I can give to the client as well. We can also frame highest and lowest rated movies for every month in a particular year. So you know that in every year the movies are released. Okay. If you want to give your client a metric that tells them that, yeah, if you want to recommend a movie to your users, that which is the movie that you have to you can watch in this particular month, you can get an idea by getting the most popular movie in a particular month, by seeing the voting rating, or by seeing the popularity, all those things. So you can get an idea of that as well, and that would be helpful for your client. So you can get those information that can help you eventually in your building the case study. Is this clear to everyone, that how you can proceed towards the problem statement? Is the idea clear to everyone? Clear? Hmm. Correct. Let's move ahead. So now the first idea is to remove that unnamed column, because that unnamed column is not doing any benefit for me. This unnamed column is a bullshit for me. I just not doing any. It is not giving me certain useful information. And if it is not conveying some useful information, let's remove the waste. Okay, so what we are trying to do, we have done. Just give me a second. So what we have done, we have written movies is equal to pd.read.csv. Okay, then what we have written movies.csv, and we have written index column is equal to 0. It means that I want my index column to be named as index column should not be present. So if there is an index column that is there in my data, I don't want that index column here in my data frame. So what this command has done, it has removed that unnamed column which has occurred here. You can see this unnamed column which has occurred here. I have removed that unnamed column by writing index call is equal to 0. So anytime in your case studies, anytime in your projects, if you have ever encountered that unnamed column, by mistake it has been present, or let's say it is present in your dataset, and you want to remove it, you can simply write index call is equal to 0. And that will help you to remove that column, and you can see the data frame without that unnamed column. Okay. Now movies.shape. Simple command that helps you to get the how many rows and how many columns are there. Since it's a data frame, so we'll have rows and columns uh, together in a data frame. So what you can see, we have 1, 4, 6, 5 rows and 11 columns are present in my data frame. Okay, this is the second insight that we got. The third thing is, let's import the director file as well. So director file also has this unnamed column. Getting a point? This also has that unnamed column. I want to remove this column as well. How we can do that? I can simply write pd.read.csv directors.csv index call is equal to 0. As soon as you write this, you'll get this directors.csv file in this format. So now your movies file and directors file is free from that serial number column, and you can see this in a very refined way. Okay, similarly you can do the directors.shape. What you can see in the directors, that there are 2, 3, 4, 9 rows and 3 columns that are present in your directors data frame. Up till this part, is anyone having doubt anything? Is anyone having doubt, or is it clear to everyone? Can I get a quick yes up till this part? Simple things. We've done all these things in the previous classes. Hanji, great, great. Now, see, if I want to work on this movies, okay, if I take this movies dataset and if I take this directors dataset, okay, if I want to work on this two dataset collectively, remember the things that you have studied in the joins in SQL. Can you join them using a common column? Can you join these two tables using a common column? Which column you are finding common in both these tables? Can you all tell me? You have the data. Can you all tell me this is one table, this is the other table? Very good, very good. So what we can see, that there are one column which is common in both the tables. So we can see director ID which is present here, which denotes the director's ID, is present in this table, and this column is common with this table. So you can see this ID here, which also depicts the director's ID. So although the column names are different, but both depicts the same thing. So yeah, if I have been given an opportunity, I can join both of these tables using a simple join by making this ID joined with this director ID. Clear to everyone? So what we will do? We will join this. Okay. So first we'll do one thing. We'll see the number of the director's ID and unique here. So movies director ID dot n unique, and we find out that there are 199 unique directors which are present in the movies data frame. 199 unique directors which are present in the movies data frame. Okay. While if I see directors ID dot n unique, what do we see? We see 2349. It means that in the directors data frame, okay, let me write it. In the directors data frame, there are 2349 unique directors. But if I see the movies data frame, there are only how many directors? 199 directors. 199 directors. What does that mean? Can I say that this means that all the directors which are present in my directors table, they have not produced the movies? Yes or no? Can you say that? All the directors in the directors data frame might not have produced the movies in the might not have produced the movies. Can you say that? Because directors unique are 2349, such a great number. But if I see the movies data frame, I can see only 199 directors. It means that most of the directors have not produced the movies, or they are not present in that data frame. Is this idea clear to everyone? Is this idea clear to everyone? Yeah. Hmm. Great, great, great. Awesome. So let's move forward. Let's move forward with that vision. So this thing is clear to us. Now, if we want to see that which director ID is present in my which director ID in the movies is present in my director's data frame. So what we have done? We have written movies director ID dot is in director's ID. Means we want to check whether each director ID which is present in the movies data frame, is it matching with the ID column in the director's data frame, and we are going to get a result like true and false. Now, dot is in function, it simply tells us, it gives me a boolean value at the end of the day, whether that data is present or whether data is not present. Now, although this information looks fruitful to me, but it is not giving me enough information about which director IDs are present, which director ID is not present. So, yeah, it gives me an idea that, yeah, whether director ID is present or not, true or false, but I cannot analyze and see all those roles. I do not have time. I do not have. You cannot see that in the preview option, right? I want something very sophisticated, in a very sophisticated and very concise way. So what we have done, we write np.all movies director ID dot is in director's ID. So what this, huh? Let's check that. So what we are going to see from this np.all, np.all means all the condition has to be true. All the condition has to be true. np.all means it's a simple and condition. So what it is in and condition, movies director ID should be in the director's ID data frame. If even a single condition is false, then I will get false as result. So to get it true here, every movie director ID should be present in the director's ID data frame. Then only we'll get a true, otherwise we'll get a false. So what we got, np.all movies director ID dot is in director's ID, and we got true. Can I say that? It means that all the movies directors, all the director IDs which are present in the movies data frame, all are present in the director's ID data frame. Can I say that? Yes or no? By this simple analysis, can I say that all the movies directors that are present in the movies data frame are present in the director's data frame? Can I say the vice versa is true? Is the vice versa true or not? If I tell you that all the directors in the director's data frame are present in the movies data frame, no, it's not true. Array, directors data frame is the whole holistic group of all the directors, whether they have directed, whether they have not directed. But the movies data frame has only those directors which have directed the movie. So if I write np.all movies directors ID dot is in directors ID, what I get true. It means that all the directors which are present in the movies data frame, they all are matching, or they all are, we all got them in the directors data frame. So we got a true. Okay, great. So if I ask you, okay, here I have directors table, here I have movies table. Okay, here I have directors table, I have movies table. If I want all the directors in my final data frame, which type of join should I make? If I want all the directors in my final data frame, which join should I make? All the directors in my final data frame. You are all studied about joins? Answer me. I want answers from all of you. If I want all the directors in my final data frame, Which join should I use? I still am not getting response from all of you. I want answers from all of you. Very good. Very good. All are correct. We would be moving using a left join if I want all the directors in my final data frame. Because left join, what it helps me? It helps me getting all the records which are present on the left hand side plus matching records on both the tables. So if you want to get all the directors, you'll have to do a left join. As simple as that. Okay. Now here we have done the same thing. Can you all see and let me know, is this clear to everyone? Data.merge, and we are merging using left join by taking director's ID on left hand side and right hand side we are taking the ID. Is this clear to everyone? Let me know if it is clear to everyone. Clear? Great, great, great. So here, if you see, now have I have made a join and let me, hmm, I made a join and you all can see the results of this join. Wait a second. Huh. So you see the ID X, the budget, the popularity, the revenue, the title, the vote average, vote count. Okay, all the X columns, all the Y columns of both the all the columns of both the different names. If the column name are same, how can it identify which will be left and which is right? You have to explicitly write here, right, Ranil? That which is your left column, which is your left on, right on. You have to write on which column you're joining. So in Python, we generally specify here. Okay, so you have to write left on the same column name, right on the same column name, and then you can make a join. Clear? Huh. So here we are joining both these tables, and you can see the column names of both these tables appearing here. We see the director ID here as well. We see the ID column here as well. We see the director name as available here as well. We see the gender here available as well. We see everything available here. Here. So this is the merged data frame that I have. Okay. Now, very interesting thing that I'll showcase you here. Let me first go here. Huh. So here, if you see, there's an ID column here. Can you all see an ID column here in movies data frame? Can you all see an ID column here in movies data frame? And I have a ID column here in characters data frame as well. But if I make a join on both these tables, how will the resultant table looks like? So if I showcase you the how the resultant table looks like, so Python knows things very intelligently. So what it will do, it will make one column ID underscore X. It will make one column ID underscore Y. This ID underscore Y stands for the director's ID, which we have in the director's data frame. And this ID underscore X is basically for the movies that we have in the movies data frame. So Python has explicitly mentioned and converted these ID columns into steps so that we can not get confused that which ID belongs to which data frame. So ID underscore X, default naming by Python, ID underscore Y, default naming by Python. It has done ID underscore Y, ID underscore X. This is how it gave you. So what I've written here as well, two strange ID columns, ID underscore X and ID underscore Y. ID underscore X represents ID values from movies data frame, which I have told you. This is movies data frame ID column, and ID underscore Y. If I told you this is a director's data frame. ID values from the director's data frame. Okay. Now, one thing which you can see. Can I say that this director ID and this ID underscore Y are the same things? This director ID and ID underscore Y are the same things. Let me know. this director ID, this ID and scroll by are the same things. Yes or no? These are the director IDs. These are director IDs. So I can drop one of them because either this or this is one of them is redundant for me. It is not important for me because one is giving me enough information. Why to use two? They both are replica of each of them. So what I'm trying to do, I am going to drop one of the column because that is not making much sense to my data. See, in a data analysis problem, in a machine learning problem, you have to reduce your noise. More the less number of columns, more better is the output because less confusion you will have. So we try to remove the redundant columns which does not pay or does not have any much significance in my whole analysis. So here id underscore y is not giving me much significance. So I'm going to drop id underscore y because director id is the column that is giving me all the information. Okay. So what you can do, you can acha, here I don't know why we are dropped why I've dropped both of these columns, but yeah, you can drop either one of the column. Okay, you can drop either one of the column director ID or ID underscore y. You have to write access equal to 1, and then you're going to write n place is equal to true. That will help you to get the data that looks something like this. Okay, you can keep one column. I don't know that why I have used and why I have dropped two columns. But yeah, you can use and drop one of the column because one of the column is redundant for me. Both things conveying same thing. I guess I have dropped by because director ID we have the director names. So I might have thought that director ID does not have a much significance. That is why I have dropped both of them. But yeah, what you can do, you can drop either one of column director ID or ID underscore y. You can write access equal to 1. Why access equal to 1 is written? Because you are dropping a column name. If you're going to write access equal to 0, you are going to get an error, and you are going to write in place equal to true. In place equal to true because you want the changes to be permanent. As soon as you run this, you will see a data frame like this. Let me know if everything clear up to this part or not. Fast folks, see this and let me know if it is clear to everyone. Clear? Things are simple. Hmm. Great. Awesome. Let's move ahead. If we are clear with this, let's move ahead. Hmm. Now let's learn a function. Let's have a function. Uh, see, if you see this data set, okay, at the end of the day, see, computer only understand two things. It understands the binary languages, okay, 1 and 0. So any column which is in the object format, which is in the either the string format or object format, we have to in one or the other way convert it, or we try to convert it into a number like thing. Okay, if it is possible, right? I'm not saying that every column you have to convert because that is not possible. But yeah, we try to convert the columns in the form of numbers because computer understands the numbers well. And machine learning models, if you're going to build at the end of the day, that require input only in the form of numbers. So it's always a better idea if we can convert a column which is in string format or a object format. If I have the opportunity, if I have the way to convert them, I can convert them into the form of integers. Now the first thing that I can check is, okay, so let me first run this. Okay, I guess I have not run this. Okay, just give me a second. This is done. This is done. Huh. Okay. So if I showcase you one thing here, please here. So I'm going to write np dot n unique. Okay. And we are going to write df or simple write df gender dot in unique. What is the data? Okay, sorry, data one. Q and I. Okay, spelling mistake. So what do you see here? Can you see this? That if I wrote data gender dot n unique, what do you see? I am seeing only two number. Why this so? Can anyone tell me? Can anyone tell me that why I'm seeing only two number here? Very good. It is because that tells me that there are only two categories in the gender which are available to me. Okay. If I showcase you the category by removing this, you see male, there's a value NAN which stands for that there's blank value here, and there's a category called as female. So there are two types of gender which are available with me. Either it is male or it is female. NAN stands for that it is a blank category. We'll not focus on this for a while because that holds a different significance. We'll discuss this later. But that tells me that male and female are the two categories that exist in the data gender. So can I convert these two categories into numbers? I can convert them. How? So in Python, we follow a thing called as encoding. Okay, encoding. So we try to encode these two categories, male and female, as numbers. How? We can name this as number 0. We can make this as number 1. Does not matter which you give number 1, which you give number 0. That is not an issue. This is what we call as label encoding in Python. So if you are going to encode your categorical feature, this is a categorical feature. Why I'm calling it categorical feature? Because it is in a string format. If I am going to encode a categorical feature which has only two categories, then this label encoding is very helpful. Now, there are different types of label encodings that we'll study once we go on a deeper part. But understand the two types of encoding, this is the encoding which is called as label encoding, where the labels that we have, male and female, we are giving either number of 0 or we giving number of 1. We generally try to give 0 and 1 only. Do not get any other number. You can give, that is not an issue. But we try to keep the problem very simplistic, and 0 and 1 are the base assumptions that we can make. So either you can give male as 0 or you can give female as 1. Not an issue. You can give either of them. Okay. And vice versa as well. So encoding, this is called as label encoding in Python. What it is called as label encoding in Python. We are going to convert your categorical column into the numeric column. So you can convert this from a categorical column to a numeric column. How you can do that up? You can do that up by simply writing a function. Which function? So what you can see, def encode is one of the functions that I started with. Data. If data double equal to male, return 0, else return 1. This is the function that I wrote. Definition def encode data. If data double equal to male, hey, return 0, else return 1. So this is a function that I wrote. Now I'll use this function to apply on my complete data frame of gender. How I'll use it? So this is the function that I have. I have the data frame of gender like this. What I'll do, I'll use data.gender dot apply. So apply is a function that helps us to apply a predefined function that I've created, on a particular data frame. In this case, the data frame stands for or series. The series stands for a data gender. So I'm going to apply this function on the top of this data gender, and I'm going to perform all this. See, I cannot do for each and every row. So this apply function does the work for me because it goes through each and every data set, every data point in my data, and it applies that function. And if you see your data again, you see the category of 0 and 1 appearing like in this way. Can you all see this? That 0 and 1 are appearing in this? Yes or no? Is this clear to everyone that how the encoding is happening? This is called as label encoding. We have a library of label encoding as well, but I will not teach you here. We have a separate class for that, maybe in the maths and stat or in the, what do you say, in the maths and stats. So we'll cover in the machine learning part. We'll cover there. But yeah, data gender dot apply encode is one of the library or is one of the function that help us to convert or apply a function on the top of our data frame, and this turns our data frame into the form of numeric numbers. Okay, I hope this is clear to everyone. Huh. Now we are going to apply certain similar functions here as well. We have data, revenue, and budget. Let's say I want to apply a function np.sum. Now this is a predefined function in NumPy. np.sum. Everyone has learned through this. Okay. What we are trying to do, we have two columns, revenue and budget. Since we have two columns, so we are using two square brackets here, two square brackets here, two square brackets here, and we're going to write apply np.sum. Now here we are not defining a function here. Why? Because we know that there is a predefined function occurring in NumPy, that is np.sum. So we're simply using it, and what we are trying to find out, this is simple function that we have in SQL, sum of aggregation function. So sum, it calculates sum of revenue, it calculates sum of budget. Encode is predefined function. No, encode is the function that we have just created it. Mahi, we have just created that function. Okay, it's not a predefined function. But np.sum is a predefined function, right? We know that this function helps us to calculate the sum of a list or an array. So what we're trying to do, revenue and budget, two entities we have taken, and now we are going to get, hey, give me the summation of revenue, give me the summation of budget in the whole column, in the whole data frame. So what you got here is revenue stands for this number and budget stands for this number. Is this clear to everyone? That how the total revenue and total budget for all the movies is being calculated? Is this clear? Can I move ahead? Everyone, first, see this. I want yes from all of you if you're clear with this. Post Fox, clear? Hmm. Okay. Now, so this is with respect to the complete, okay, the complete data frame. But let's say we want the results, let's say for every movie. I want the revenue for every movie. I want the budget for every movie. Can I do that up as well? So yeah, I can do that as well. How? I can simply write revenue, I can write budget, I can write apply np.sum. Now I have written x is equal to 1. Now here I am getting this as the summation of all the columns. Previously, I have not applied any x is equal to 0, x is equal to 1. But here I have written x is equal to 1. It means that with respect to all the columns, the revenue and your budget is displayed here. Okay. So x is equal to 0 stands for each column. And when I talk about x is equal to 1, we have discussed this multiple times. X is equal to 1 for each row. Since we are using x is equal to 1, it means that for each row, we are calculating the separate budget and separate revenue. That is the idea behind this. Okay, these are different entities which you can try from your end as well. X is equal to 0, all the column summation. X is equal to 1, each row summation. I hope this is clear to everyone. Okay. Now, let's calculate a new column. Okay. This is budget and revenue, all these things we have. So now we are going to calculate a new column. Now the art of calculating a new column here, art of calculating a new column is called as feature engineering. Is called as feature engineering. It means that on the top of your data, you are creating a new column. So what you're trying to create here is we are going to create a column called as profit. How profit? We are define a function def profit. We return, hey, return revenue minus budget. Okay, this I've written. Revenue minus budget. This is the function that I have just written. Now what I've written, data profit, create a column called as profit. What is the profit column? Data, revenue, comma budget, dot apply this function. What is this function name? Prof. I've written prof here. And how I want to apply? Across each row. So you'll see the profit appearing, but you have the budget. Okay, if I showcase you here. So you have the budget for each row, you have the revenue for each movie, and you have the profit. How you can calculate profit? Simply your budget, revenue, subtract them up, and you'll get the profit for each row. So what you have done here, you have simply created a def, let's say prof. Okay, you simply created and let's say this is data. What you have done? So you have just created, hey, return the return the, what do you say, revenue minus budget. So this is what is profit. I have made a similar function here. Def profit x, return, this is your revenue, this is your budget, this is your function written. Now how you have to apply this function? You have to create a new column called as data profit, because it is not in your data frame. And how this data frame is calculated? This profit is calculated. Data, revenue, budget. You take this from your data and apply the function prof x is equal to 1. Now this data, okay, as soon as you apply this, so this data goes, if I take a screenshot of it to explain you this. Let's do this. So this entity goes in this X and hey, writes, hey, I have revenue, I have budget. So data revenue goes here, data budget goes here. And that's how you calculate the profit for each and every row through the apply function. And now if you see the output, you'll see, what do you see? You see a profit column appearing here. Can you all see a profit column appearing here? Yes or no? Is this clear to everyone that how this function is getting calculated and how you are able to calculate it? Let me know if it is clear to everyone. Huh. Could you please explain how X is defined? Okay. For that, I have to unmute you. That's it. Okay. Yes, Dad. Over to you.
Yeah, I just wanted to understand why uh, profit is taken into as a X.
Profit is taken as X. Okay. See, this is that in parentheses, I have to define any one of the, I have to take something in the argument part. Okay. So here you can
Mm-hmm.
define I, you can define X, anything. The moment is that if you are going to write here, okay, if you're going to write here, X is a basically a data frame. Okay, X is a data frame here.
Mm-hmm.
Now what you're doing, hey, you're writing a function. In this function, you have a data, in this data frame, you have a revenue column,
Mm-hmm.
you have a budget column. So what you're trying to do, hey, replace this X with the data now. This is the function you have created. Now, once you apply this on the top of this prof, okay, so what you're trying to do, hey, now this X is equal to data. So everything what
Mm-hmm.
you're trying to do on X, similarly replicate for this complete data. So now as soon as you write dot apply prof, this whole function gets called up here. This whole function gets called up here. And hey, this X is replaced by data. And that's how you calculate the profit for each and every row. So now your X is replaced by your data and you calculate
Mm-hmm.
data revenue minus data budget.
Is equal to profit.
Clear?
Yep. Yep.
Great, great. Is it
Thank
clear with everyone else? Can I get a quick yes from all of you if you're clear with this part, that how the function creation is happening, and then on top of function creation, you are going to apply that function on the top of your data frame. Can I get a quick yes from all of you if you're clear with this part? Fast, folks, fast. I'm getting only few yeses. What is happening with others? Akshay, Amin, Ankita, Anshul, Ashraf, Karan, Megha, Sameer, Saurabh, Shivangi. Clear to everyone? So if you're not asking me, and because these are very important concepts, okay? If you not understand these facts, very important these things are. You will find these uh, things getting used in one or the other analysis. That is why I say that these things are very important. Hmm. Okay, great that you all have understood. Let's move to the next part. Acha, everyone knows grouping, so we'll directly go to the part of grouping. Okay, we'll not all these things. Hmm. This is not important, not important. See, everyone, I guess, has gone through the SQL lectures. In SQL, we have a statement of a keyword called as group by, and that group by helps me in getting the information with respect to that entity. If I use, let's say, okay, let me take you to the same example. Let's say I want the content of a director. Let's say uh, Christopher Nolan. Christopher Nolan. What I can do? I can simply write, hey, select, let's say, count of all movies done by him. Okay, movie ID, some budget, okay, budget, average, vote average, okay, all those things from, let's say, data. And let's say here I have the director ID, director name as well. Okay, director name as well. And here I do group by director, group by director name. And then what I'm going to write, where director name is equal to Christopher Nolan, something like this. It's a using of ampersands. So what you're trying to get, you are going to get the with respect to Christopher Nolan, all the count of movies, all the budget, and the average voting count with respect to Christopher Nolan. Yes or no, folks? This is how the query you write for getting the information with respect to Christopher Nolan. Yes. How we can do with respect to this simpler thing, how we can do and get information with respect to a director. Let's say we know a director. Let's say the director is Alexander Payne, and you want to get all the information with respect to that. So to get that without aggregation, here there we have performed aggregation. Here we are not performing any aggregation. You will just be simply doing data dot group by director name get a group of Alexander Payne. It means that give me all the data with respect to the Alexander Payne. Now, this could have been done with a different way as well, where you can simply filter out the values with respect to the director Alexander Payne. That could also be a way. But if you want to group by and perform certain operations on top of it, this is one of the command. If you do not know about this command, no need to worry because that is not required. This information you can get. Sorry, this information you can get even with simply applying filter data director name is equal to Alexander Payne. Okay, that can also fetch you the same information. But yeah, this is also a way that you can get the information that yeah, Alexander Payne, all the information with respect to the budget, popularity, revenue, title, vote average, along with gender and a profit can be seen here. Now, on the top of this director, you can perform certain more operations. So this is one way. But can you do aggregation on top of it? Yes, aggregation on the top of it is also possible. Let's say I want to use group by data.group by director name. And what I'm trying to see, how many movies each director has directed. Okay, so what I'm trying to do, data.group by director name, title.count. Director name inside the square, inside a simple bracket, grouping by on the simple director's name. And what I'm going to write, title.count. So it is trying to give me the list of directors with the number of movies each director has directed. Can you all see it? That it gave me a list of directors with the number of movies they have directed. Yes or no? Is this clear to everyone? So this is the first aggregation that we can perform. Now everyone knows that there are different types of aggregations. In SQL, similarly you're going to use here. Count ho gaya, min, max. Okay. average. All these are called as aggregations in Python or in SQL. So similarly here, we can use different aggregations. Let's say I want to use aggregation in the year, the first directed movie and the last directed movie. So what you can see, min and max with respect to year tells me that which is the first directed movie by that director, which is the last movie that directed by this director. Can you all see this? The same information. Data dot group by director name. This time I use year. And what I've written dot aggregate. Previously, what I've written dot count. This has done work for the counting purpose. But if I want the count, if I want the aggregation with respect to min max, sir, I have a little out. Yes. Can I unmute you? Just give me a second. Yeah, Nabil, over to you.
Sir, in this function, we are using parentheses and square bracket, and sometimes you are using colleagues bracket. So how we can get ideas here where you need to use parentheses, square bracket?
Great question. See, here we are using the square bracket. Why? Because we are wanting aggregation of two things, min and max. Now, if you are wanting aggregation of a single column with respect, aggregation of with respect to single column and two different entities like min and max. So at that time, this is a syntax of Python that if you are going to use this in director's name, you're going to write in square bracket y because you're going to use aggregate min and max. Let's say you have to write a single entity. Okay. Then even a symbol bracket would do the work. It depends on syntax part, and believe me, no one is going to ask the syntax part. No one is going to ask the syntax part. Hey, have to simply Google it. You have to go and do the practice part. Even interviews, no one, even I do not. Sometimes I forget the syntax. That is completely fine. See, syntax is anything that the interviews also do not focus upon because they know that syntax could be learned from the Google, or they can simply used from the can be taken help from the Google itself. That is not an issue. The idea is that whether you understand the fact that why I have used this min and max for this director name. Getting a point, Nabil. So the answer to your question is that since we are wanting aggregation of two things, that's why we have used a square bracket here. Had I wanted aggregation with respect to one thing, let's say count. So here I've used a simple bracket that has done the work. Okay. So what you see here, director's name, min and max years are displayed here. Director's name Adam McKay, Adam Shankman, and all these directors' name with the min and max values are being displayed here. Okay. Then let's say I want the next thing. What I want now, I want the so now you can see director's name. I have written dot max. Now you cannot see a square bracket here. Why? Because I am wanting the aggregation with respect to a single entity. What I'm now looking for, I am looking for, hey, I want aggregation based on the max value. So director's name, the budget, the maximum budget made by that director. Okay, the maximum budget movie made by that director. So what I've written, data dot group by director's name, budget dot max dot recent index. Why recent index written? Because I do not want to retain the explicit index. I want to write the or I want to get the implicit index. We have discussed what is implicit index and explicit index in the previous class. So I hope everyone is aware of that. Okay. Since we do not care about the previous indices, we have used the dot reset index. Then what I've done? Data dot group by director's name, budget dot max. Why we have done this? To get that, which director, how much, what is the maximum budget for each director that he has ever done the movie in his career. So what you can see, Adam McKay, the maximum budget he has worked in was this much. Adam Shank, this much. Alexander, what's Gonzalez, this much. Alex Proyas, this much, and Alexander Payne, this much. So this is how I got the information with respect to directors. Now here I've written dot head. You will get a list of directors, but let's say I want only the 5 directors, only 10 directors. I can get an idea, hey, the maximum budget pays post by those directors could be got in this way. Clear to everyone? Simple things. These all things we have studied in SQL. That's why these things are not very difficult, I hope. Syntax might be intimidating, but yeah, once you practice on those things, things will become easy. Is everyone clear with the concept part? that how we have used this director name along with budget to get the max value. Clear? Any doubt in this part? Hmm. Now, can we apply a filter on the budget as well? So can we apply filters on the top of it? Answer is yes. How? You can see it. So now what I've done, I am looking, I am looking for the data. Okay. I am looking for that. Let me showcase you once. So let me run this. Okay. Then let's what I can do here is uh, 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 uh. Okay. Showcase you this. Created a column name. Let's move this profile. What you're trying to see here? Let's forget this for a while. See, what we've done now, I want the movies, I want those directors' name whose budget is greater than, let's say, 100. Okay. I want simple thing names. Now, there are two ways to do this. First, we can filter out the, let's say we have this data. Okay. We have this data of data DIR budget where we have the director's name as well as budget. Now, we can do two things. First, we can filter out the directors who have the budget greater than 100. We can do that as well. Second, what we can do, we can filter out the indices and we can remove those indices from from my data dir budget where the data where the budget is less than 100. I can do that as well. So what I've done, I have used data dir budget dot loc, and what I've done, hey, include those directors, include that data where greater than budget is greater than equal to 100 and give me those directors names. What I've done, names is equal to data dir dot budget. Hey, give me those indices where, or give me those names where budget is greater than equal to 100 and only the directors names. So if you're going to write this and you're going to get this, if I'll showcase you, can you all see that I'll get a whole list of names here where I'm simply interested that, hey, give me the names of directors where the budget is greater than 100. So data dir budget dot loc has simply gave me the indices, have simply gave me the indices or the director names where the budget is greater than equal to 100. And you can see the same information displayed here. Directors names, and you can see the all the director names present here. Let's say you want to check that whether these names are present in the original data frame or not. Okay, whether these present director names are present in the what do you say, directors names or not. So what I'm trying to do, data.loc data directors name dot is in names. Okay, so now once we have this data directors names, once we have these director names, what we're trying to do, we are trying to get the information of all the directors. We are going to get the information of all the directors which are in this names. For how? Data.loc data directors name dot is in names. So this is the complete data that I have. Now I have these director names. I want the information of only those directors. What I've done, written dot alloc data directors name dot is in names. As soon as I run this, okay, as soon as I run this, this has given me now the list of data which only contains the information of the director names that are thus displayed here. So it's simply what I'm trying to showcase you here is that first we are filtering the information, filtering. Then we are finding the indices or rows, indices, indices. How? Through LOC command. LOC helps me in finding the indices. Once we have found the indices, we are using the power of indices, to filter the whole content. You'll find Tarang in SQL it is quite simple. Why it is complex in Python? So yeah, certain things are quite easy in SQL. I completely agree. But in Python, the things are not complex. The idea is that we are never told about these functions, or we are not told that how to use these functions in the real world. That makes these things difficult. So we are the first filtering, then we are getting the indices. Using the power of indices, we are going to filter the whole. We are going to apply the filter on the whole data to get all information. To get all info. These are the three steps, second step and third step. So this is how the steps are being carried forward. Let us go through it once again. Okay. So here we got the directors where we have the budget for those directors and the budget with the name of directors. Then what we have done, we had applied a filter on it and we wanted the, what do you say? We wanted the indices. We wanted the indices. We wanted the names, that what are the names for those directors. Okay. So how did we get this? We simply applied, hey, data underscore dir dot budget dot loc, and this simply gave me the names of all the directors which are present, which I have a budget greater than 100. So with the simple use of filter, we and the use of lock, we have got all the names. Now using these names, we are using these names on the complete data frame. How? Using the same names as the indices in the complete data. So what we're trying to do, so names we have here like this. We are simply going to apply data.loc, data, give me the complete data when the director name matches with the names. So as soon as you write this, you will see a data frame that will have the information of directors, which will have information with respect to the directors that I have just filtered out. Is this clear now to everyone that how the things are happening? Clear? Let me know if it is clear to everyone. If it is not clear, type no, not an issue. We'll discuss this again, but it should be clear to everyone. Can you move ahead? Can we move ahead, folks? How many people we have? 24 people in the house. Clear to everyone? Okay, okay. Let's move ahead. Acha, now have we discussed about lambda function? I guess we have discussed about lambda function, right? Or have not we discussed of? Have we discussed about lambda function or not? No, okay. So, Tarang, what is lambda functions? Okay. Lambda functions are the functions that are basically called as one-liner functions. So whenever, when, see the previous what we are going to write, what we have written, we had written the complete function in 2 to 3 lines. Let's say someone says that I want a one-liner function that will do all the power. Okay. Let's say lambda x such that x mod 2 double equal to 0. Answer it yes or 0. What does that mean? It means that, hey, I have defined a variable x. If x mod 2 double equal to 0, if means x mod 2 double equal to 0, print get me if it is even, if it is 1, if it is even, give me 1, if it is odd, give me 0. So what do you see? That this is a simple one-liner function, and in spite of writing the whole function, if x mod 2 double equal to 0, then return 1, else return 0. In spite of writing that whole code, what I've written, I have done the whole code in one single line. So lambda, in short, if I want to tell you, it is a one-liner function that does the same thing as we define a proper function, nothing else. What is syntax? We write the keyword lambda, we write the variable name, then we write what is the entity that you have to write, and then we write how we have to return the output. Let us see through an example to get the more idea. So here, data.group by. Okay. So previously we have done all these things. Okay. Now we want data.group by, give me the directors names, dot filter, apply a filter, and filter such that lambda x such that x budget means each budget dot max should be greater than equal to 0. Understand how important this function. Let me copy this function here. That group by my data with respect to director names. Let's say I have director A, I have director B, director C. Now filter, apply a filter, dot filter is a function that helps us to apply a filter directly. So dot filter is a function that tells us, hey, you have the complete list. Let's apply filter at last. What are you trying to get? Lambda x, this lambda x such that, this is such that, this is such that X budget. It means that let's say X is a data frame and X budget dot max. So find the maximum budget in X. Now in our case, the X is our data. X is our data. So this data is our X and data budget dot max. It means with respect to each director, we are going to get the max budget A, max budget B, max budget C. So through this lambda function, okay, and this max budget should be greater than equal to 100, should be greater than equal to 100, should be greater than equal to 100. So what we are trying to get, we are first going to calculate max budget, and then we are taking it greater than equal to 0. So at the end of the day, lambda function is helping me to calculate the whole maximum budget with respect to each director and filtering the data on a simple condition that is greater than equal to 0. Max function ends here. Max function ends here. But what we are trying to do, greater than equal to 0. This is with respect to the filter function. So multiple functions has been used here. Filter function. This is with respect to lambda function. Lambda happening here. Lambda function. This is the filter condition. Filter condition. And this is the group by aggregation. Simple. So we are using all these things in a single line. And that is the beauty of this lambda function, because instead of writing the complete code, lambda is saying, hey, create a simple function, lambda x budget dot max. And if you're going to apply a filter on top of it. So what am I trying to apply a filter? Hey, budget should be at the aggregate, the max budget of each director should be greater than equal to 100. So at the end of the day, we are only going to get the directors which are having the budget greater than equal to 100. Is this clear to everyone? Can I get a quick yes if it is clear to everyone? Answer me if you have not clear, not an issue. But answer me if this is clear to everyone or not. Okay. Let me unmute Naved for a while. If it is. Yes, Naved, over to you. Can you hear me? Naved, I cannot unmute you. Uh, can you help me to understand that which part is not clear? Yeah. Okay, okay. So I guess everyone is clear with the things that how the lambda function is helpful. Always remember that lambda is a one level function which is doing the same thing as your simple function definition, nothing else. Lambda is the same function. Data dot group by director name dot filter. This filter condition is for greater than equal to 100. Lambda x such that budget is budget dot max. It means that for each data frame, for each particular row, I will be calculating the max budget. And that is how we are going to arrive to the naming part. Okay. So now you see data dot group by. It means that now I'm grouping the data on a simpler thing. I don't want to filter the names and all those things, fancy things. Simple things. Data dot group by director name dot filter lambda x such that x budget greater dot max greater than equal to 100, and that does the work for me. Clear? Okay, things are pretty simple here, so let's so this is done. Cool. Huh. Now, let me take you to this part. So, what we are trying to do is now that we are trying to understand that which director has produced the largest number of movies. Which director has produced the largest number of movies? Okay. So, what I've written data dot group by director name, title dot account. This you have discussed. That helps me to get the director's name with how many movies they have done. And then we have written dot sort values ascending equal to false. Now we have discussed this function in the NumPy class, I guess, that sort values is a simple function that helps me to sort the values on the basis of ascending or descending order based on what is written in the parenthesis. By default, it will always sort in ascending order. But let's say if you want to sort it in a descending order, what you have to write? You have to explicitly write here ascending is equal to false. So if you're going to write ascending is equal to false, you are going to get the director names along with the count of movies in the descending order. So you see Steven Spielberg, 26 movies, Clint Eastwood, 19 movies, Martin Scorsese, 19 movies. So these are the directors who have who have directed the maximum number of movies. Okay. Now again, I'm telling you, does this highest movie making director, can I say that is the most productive director? Can I say that it's the most productive director? Everyone. Can I say that this director is the most productive director? Again, answer is no. Because maybe this director has directed these movies way in the past, but he's not active currently. Yes or no? So we have to check that most productive director is a different thing and total number of movies is a different thing. How? Let's check that. So for that, we have to get which thing? We have to get the min and max here. Yes or no? For that to know, we have to get the min and max here. Because once we know the min and max here, only then I can focus that whether he is the most productive director or not. So what we are trying to do? We are going to calculate uh, right here group by, since we have used multiple aggregations, that is why a square bracket here, director name, year title. So we are going to get director name, year title, and year title we are going to get the min value, the max value, and the title we are going to get the count. So this is the things that we are going to get from the data. How we are trying to group by on directors, year and title. Okay, aggregate. So director's name aggregation. Oh sorry, grouping by year and title. We are going to perform the aggregation. Year, two aggregations, min and max. Title, only one aggregation, that is count. This is how we are going to write this. And once we run this, what we have got, we see that Adam McKay, year min 2004, the first rated movie. The last rated movie was in 2015, and total movie count was 6. Adam Shankman, 2004 is the first movie, 2012 second movie, and title count is 8. Nowhere close we see Steven Spielberg. Steven Spielberg is nowhere close. So maybe he's a very old director who has directed too many movies. Yes or no? This is a very old director who has directed many movies, but he's not directed correctly. I can see that in the recent years, maybe he's not the most active director. Okay. What next? So we got information that yeah, Adam McKay, Min and Max years 2004, 2015. These are the dates, and these are the this is the director name, that the Min year, the first movie directed and the last movie directed. What we can found, we can find a difference between these 2 years. We can find the difference between these 2 years. What we have done? So to get that, what we have done, let me showcase you that. Huh. So we are what we are trying to do. We are going to get this years active, and how we are going to calculate? Again, feature engineering, data ag years max minus data ag year min. So you're going to calculate a new column, that is years active. That will give me the difference between the last year, the recent year, and the first year. So what do you see? Years active, 11 years he was active, 11 years he was active, 15 years he was active, and different directors who were active in different years. Did you got an idea that how the years active is calculated? Can I get a quick yes if you got an idea that how years active is calculated? Simple things, sir. See it. If you got an idea that how years active is calculated. Let me know if it is clear to everyone. Clear? Huh. See, so years active is calculated. Now, what do you want? We want the divide of total count divided by years active. Because total count divided by years active will give me that the average movie produced by each director in each year. Can I say that? If I divide total number of movies divide by years active, that will give me what that will give me? That will give me the number of movies directed each year. Yes or no? Is equal to total movies divided by years active. Is this matter clear to everyone? Number of movies directed each year. See it? Let me know. Is the idea clear that why we are focusing so much on this analysis? Number of movies directed each year would be simple. Total number of movies directed divided by years active. That will give me the number of movies directed each year. Okay. So what we're trying to do, we are going to calculate movies per year, data aggregate, title count divided by data aggregate years active. And what do we see? We now are getting a new column that is movie per year like this. But we still want to sort it in descending order to see that which is the most active director. To see that, what we have done, we have done data AGG, sort values. Since you have to sort in descending order, what you have done, movie per year, and you have to sort this in descending order. So we have written ascending is equal to false. And what you can see Tyler Perry, very interesting choice that came. 2006, the first movie, 2013, the recent movie. And title count, number of movies directed, 9. So he's active since 7 years, and the total count movies per year is 1.2. So with respect to total, the most active director, I would name his name rather than the other person's name. Why? Because in the recent years, this person has directed more movies as compared to others. Is the idea clear to everyone? Now, this information is very useful to the client because total number of movies directed is not giving a sense. Maybe that director has directed multiple movies, but that was directed maybe 5 to 10 years back. This director, which I see, Tyler Perry, is the most recent director, which has directed 9 movies in the count of 7 years. So that's a very great number. So maybe if I want to, what do you say, uh, send or do certain analysis, I will do on this director rather than on some other directors. Is everyone getting a point that why this matrix is important for me? Is everyone getting the view that how we are approaching to the solution? We could have stopped there, large numbers movies or most rated movies. We could have stopped there. But the idea is that we have to help our client. See, at the end of the day, you have to convey business to the company. If you're not conveying business to the company will fire you. The company will say that you are no use to me because ascending, descending to मैं SQL से भी कर लूंगा. What is the extra information that you are giving to me? That is important to me. Getting a point. So movies per year would be helpful in this way. Okay, great. Let's move ahead. So this is what we have seen through this IMDb data set. Okay. Now, is the case study clear to everyone? Because we have done the case study. Most probably we have done the because this is what the maximum what do you say? The major important metric in our whole case study was this the most active director. And this is how if you solve this case study, okay, solve this case study at your end, see my solution at last, and see what else insights that you can get from this data. Hmm. Can we move to the next case study now? I'll share everything, Samir. Just wait for a while. I'll share everything. Okay. I'll do some edits and I'll share this notebook with everyone. Not an issue. Okay. Can we move to the next case study now? Yes. So I hope this case study was useful to you. Let's move to the next case study. Okay. Huh. So this case study is with respect to a medicine. It is, I guess, with respect to Pfizer medicine, if I'm not sure about that. Huh. Pfizer medicine. So we are going to take a deal on the medicine domain and we are going to deal on this Pfizer data. Let me first showcase you how the data looks like. So data looks like something like this. Okay. Date है, drug name है, parameters हैं. Here you have 130, 230, 330, 430, 530, 630. You can see all the different columns being named here. Can you all see this? Can you all see this? Yes or no? Can you all see this? That we have drug name, we have parameters, we have 130, 230. So I guess in this data set, I have columns with a time mentioned in each and every column. Can you all see that? That I have time mentioned in each and every column. That is strange thing because this data set does not come with a string name. It comes with a time frame type of data where you have column names like time. Now, this dataset is why interesting. Why? Because in this dataset, you will understand some new concept of pandas. We will not understand, we will not go into the old concepts, we will understand something new. Okay. Huh. So the first thing is that we are going to import this data. Let me import it. Hmm. Then what we are going to see that the data is all about, it is all about temperature and pressure. You can see that there's a drug name which is written here. There is temperature and pressure written here. So I guess temperature and pressure are mentioned here for every timestamp. Can you all see this? That for every timestamp, you have a temperature and pressure mentioned for each and every, what do you say? Let me download this, but I get a more overview. Yes. Hmm. Yeah. So what do you see? You have dates here. Okay. Then you have the medicine names written here. What this in? Glitazim, hydrochloride, doxetal injection, all these things. You have parameters mentioned in the name of temperature and pressure. And here you have 130, 230, 330, and all the times mentioned here in each and every column. Now, this is a very peculiar data where we never see, which we never see generally. Why? Because we never see time occurring in the kind of columns. So obviously, we have to play around with this data. We have to adjust some things. We have to see that how we can transform this data. We'll see all those things. Okay, great. So we'll go here. So as I told you, that data is all about temperature and pressure. Temperature is given in Kelvin, which is that unit of temperature. Pressure is P, and temperature is recorded after interval of 1 hour every day. It means that after 1 hour, the temperature is recorded 130, 230, 330, 430. You can see the temperature is being recorded after every hour. Okay. And these data points are used to identify the optimal set of values of parameters for the stability of drug. So we basically want to see that at which point, at which timestamp, at which time the stability of drug is maximum. Okay. We'll see that how that stability is defined, but yeah, that was the overall idea behind creating this case study. So first thing that you will do, we will import the data set. Okay, I guess I'm not imported the pandas data frame, so let me import that as well. Import pandas as PD. Huh. So you see this data that looks something like this: date, drug name, parameters, and all the values here. Now, at certain points you see here, there are blank values. Now, in Python, there is a keyword for blank values, and that keyword is NaN. That is keyword called as NaN. You have heard of this keyword in SQL as well. This keyword is called as not a number. It means that it is a blank value. Although in SQL, there's a different meaning of blank value and NaN value. but yeah, blank value and null value. But here in Python, if there is any blank value, we treat it as nan value. Nan is the keyword that we have in Python that is for blank value. Okay. So if you see any blank value, it means that it is a nan value, not a number. Okay. Now let's move ahead. So yeah, this is how the data looks like. And it has certain nan values, which means that there are some empty, what do you say, empty cells which are present in my data set. The first thing what we are going to do, data.info. Okay. So data.info, what does it tell me? It tells me the information about all the columns. You see all the columns here. Then what do you see? You see how many null values are, how many non-null values are present here. So what do you see here? 18 non-null values are present, 18 non-null, 16 non-null, 16 non-null, 12 non-null, and different non-null values are present here. How many values are non-null? It means that these values are filled with some value. Then what do you see? Date is of object type, drug is of object type, parameter is of object type, and all the other values 130 to 1230, all the values in these columns are of float type and some are of int type as well. So I can see a mix of data types. Some are of int, some are of float, some of object, some are of what do you say? Huh. So these are the primary data types that are present in my data frame. So the first thing that we see here is that 130, 230, 330, 430, 630, 730, 1230, these columns look okayish to me. But yeah, can I do something for these columns? Because these columns, I cannot comprehend or I cannot build a solution on the top of it. These columns are not giving me enough, or these are not a correct way of representation of the whole data. So what we are trying to do, we are trying to represent this data in a more friendly way, in a more interesting way. How? Let us see that. So what we are trying to do, we are trying to use this. So this is all time, right? This is all time. What we're trying to do, maybe we can try here. Maybe we can try here that all times that we have here, okay, all times that we have here, we can have a separate column of time that display 130, 230, 330, 430, and that can display values with respect to each time. Don't you think that that would be a very good way of representing this whole data frame rather than representing in this way? Yes or no? That instead of making the time as different columns, don't you think that there should be a one column which contain all the times, and that time should have all the values with respect to each and every entry? Don't you think that that would be a very good way to represent the data instead of using this way? Think yourself and answer me. What do you all think? Yes or no? Answer me first. You have the times in all the data set. Now it's a very logical way, it's a very friendly way that, yeah, instead of representing these as different columns and different entities, why not take them as a separate column, display all the times there, and display to each time, display the values. Now, can we do it in Python? Have you studied a function in SQL called as pivot? Have you studied a function in SQL called as pivot? Okay, I don't know. Okay, no worries, no worries. So we have that function in SQL as well, but let's cover in Python as well, so that we can see that okay, that function is in SQL as well. You can ask your instructor that he will teach you in the pivot function there as well, not an issue. So the idea here is that the data what you see is in the, what do you see, in the long format, is in the long format. Now you want to condense your data in a friendly format where you see all the columns condensed in one type of column, and you see all the values in the other column. So this is the unpivot structure. What I say when I say pivot means creating different columns. When I say unpivot means converting your all columns into a single column with all the entries in the next column. So where here we have different columns made, but I want these all columns to be represented as one column. So here I want my data to be represented in the unpivoted way. In Python, the way of representing my unpivoted data, is called as meld. MELT, meld. Okay. So we have in Python called as meld. This function helps me in Python to convert my data in from the column structure into condensed form so that my data looks more friendly, it looks more understandable, and I can get more information from it. Not more information, but yeah, it looks clean. How do we do that up? Let's see that. So you write pd.melt, then you write your data, that is your original data frame. Then you write id vars, okay, id vars. You write this as it is. Then write the columns that you want to melt. Data, date, parameter, drug value. These are the columns that are, okay, these are the columns I do not want to melt. See, eventually at the end of the day, which columns you want to condense? Can I say that the columns I want to condense are this? These are columns I want as it is, right? These are the columns I want as it is. I want the columns to be condensed are these columns. Yes or no? There's no problem in these columns. I'm finding these all columns okayish. But these columns I'm finding problem because I am finding these columns in different types, different kind of data. What do you say? Row columns. So if you're finding these entries in different columns, it is important that you condense these into a single column. So this part is okay, should be. This part is okay. I want to work on this part. I want to work on this part. This part is important for me. So under data, what do you write here? ID underscore VARS. It means that you do not want to play around with these columns. You want these columns as it is. So what I'm trying to write here, pd.melt data, comma, ID underscore VARS. Do not change the column data, parameter, and drug name. As soon as you run this, it means that you give authority to change the other columns as the in the concise way. So as you run this, what you see here is, you see date, parameter, and drug name are not affected. But if you see, a new column variable is created and this holds all the stems. Similarly, you have a variable new called value created and it contains all the values with respect to that entity. Now, very interesting thing you know. See, 15, 10, 20, 20, same medicine, temperature, 23, 22. Okay, 20 with respect to this. Okay, with respect to this entry, 130. We have 23 as temperature, 12 as pressure. Can we see the same thing here? 130, 23 as temperature, 130, 12 as pressure. Temperature, temperature, pressure, pressure. Can you all see the same thing? Can you all relate? But now with that one row that I had here, okay, but that one and these two rows are now being condensed in this way where I have the variable and the value name being displayed in this way. Is this clear to everyone? How the melting is happening? You are not touching these three parameters. That is data, parameter, and drug name. You're not touching them. What you're touching them? You are touching these columns. So the columns which you want to concise, you do not write in ID underscore vars. You write only those columns that you do not want to condense. I want to condense these all columns. That's what I've written. Hey, I have created a column called as, let's say, variable, and that variable column gets me all the times. There's a column called as value, and that gives me all the values. And you see the entries are being displayed in this way. Is this clear to everyone? That how melt function works? Let me know if you have any doubt. Pass, folks. If you're clear with this, like type yes. Not clear, not an issue. Pass, folks. We have 24 people in the house. Akshay, Anshul, Ashraf, Ashwini, Kamini, Karan, Megha, Ranit, Sameer, Satyabrat, Saurabh. Uma, clear? Huh. Okay, great. Acha. These Tarang, these variable name value you are not given them. They are already defined. Can we change these names? Can we change the variable to time? Can we change this value to something else? Yes, we can do that as well. How? We can simply write td.melt data. Since we want to convert this data, id underscore vars. I do not want to touch these parameter. I do not want to touch these columns. Then what I'm writing, var name is equal to time. It means that the first variable name I want as time and the value name I want reading. So the columns that you are going to concise, you're going to write that name as time, and the value column you are going to write name as reading. So if you run this, you'll get a beautiful data frame that looks something like this. Now you have the customized names, not with respect to the default names that the Python gives you. Is this clear to everyone? Always remember, if you do not want to melt any column, just give it under the id underscore vars. Okay, var name means that what is the variable name that you want to define for that new column. Var value, it means value name, it means that what are the values that column that you're going to create. This is called as unpivot. In what do you say, in data part, in data analysis part, can we write the rename function to change? Yes, 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 you can do that as well. You can do that as well. This I'm saying that this is the functionality that data.melt pd.melt offers us. You can change it with that way as well. Not an issue. Okay, because this is a part of your data frame. At the end of the day, you can use rename as well. Not an issue. Hmm? So what we have concluded that a label of timestamp columns are being conveniently melted into a single column, are being converted or concise into a time. It all retained values in the reading column. The labels of the columns such as 130 to 30 have now become categories of the variable column. So now I can say that these are categories from the columns. Can I say that these have turned into rows? Yes or no? 130, 230, 330, 430. So now these have become categories of the variable column. The values from the columns are we are melting are stored in the value column. So all the values are stored in this reading column. Okay, this is what this melting has done. Now you would say, Tarang, I had this way, I had this concise way, I had this concise way. I'll give you example. Okay, so there, let's say there is name, there is subject, there is marks. Okay, I want complete attention here, folks. Name A, A, B, B, C, C. Subject physics, chemistry, bio, physics, physics, not physics, physics, bio, chemistry, bio. Okay. Marks, let's say 60, 40, 30, 100, 70, 60, 50. Okay. These are the marks I have given. First, tell me, what do you find? Is this a concise way of representing the information, or is this a broad way of representing the information? First, if I ask you, what do you see from this data? Is this a concise way? Is this a unpivot way? Is this a melted way? Or is this a pivot way of representing the information? Forget about broad or not broad. Tell me whether it is a pivoted way or it is an unpivoted way. Pivoted way or unpivoted way. Pivot means that we are going to create columns from our categories. Now tell me, Pivoted means that you are going to create columns from your categories. Now answer me, whether it is a pivoted way or it is an unpivoted way. The format that you have seen of the previous question, Pfizer question, was a pivoted way. 130, 230, 330, 430. These were the pivoted way. Now answer me that whether this format you see is a pivoted way or it is an unpivoted way. See, it's a unpivoted way. Why? Because you have concised your information. If you have concised your information, this is a melted way. This is a melted way in Python, or this is a unpivoted way in Python. If you want to convert this format into pivoted way, things look simple. How? I'll use name column, then I'll have what do you say? Physics, chemistry, bio. Here I have A, okay, 60, 40, 30, B, 30, NaN, 40, C, 80, 50, 100, just random values. Okay. This is a pivoted way. This is what you call it as a pivoted way. Is everyone clear that what is pivoted and unpivoted? Now you are clear that it is a pivoted or unpivoted? It is a pivoted way. So the concept, the original data frame that we have seen of this marks, can I say that that was an unpivoted way? That was a melted way. We have similar information, then we had variable, then we have the values for that. Now here I have name, physics, chemistry, bio. You'll see this thing very common in SQL. Very common in SQL that someone asks you, hey, convert this format into a pivot way, convert this format into the unpivot way. Okay. You might have done a function, if I recall about SQL, okay. Done a function called as, you have used some case when, I use this something like this, case when this category is greater than 0, then this value, else. If you use some outside, this is what is called a pivoted way. This is what is pivoting happens. Very important question that someone sometimes asks is that how you create a pivot table using the simple aggregation commands. So this is the way. There's not an inbuilt function that we use. This is what is a pivoted way. Okay. So that is one thing. So now we jump to this. So let's say the things that you see here is a unpivoted way. Now, and if you see this thing, can you say that this is a pivoted way? Can I say that this is a pivoted way? Yes or no? This is a pivoted way. Yes. Let's say someone says that I have the data in this format. I have the data in this format. Convert this data into the pivoted way. Convert this data into the pivoted way. Now, Tarang, you have told us that how to convert an unpivoted data, a pivoted data to unpivoted data through pd.melt, but you have not taught how to convert the uh, unpivoted data to pivoted data. So through the command that is used to pivot the data is basically called as whatever data you have, you write dot pivot, then you write the index. In index, you used what are the columns that you have to retain. So columns you have to retain is date, drug name, and parameter. These are the columns that you have to retain. Then columns is equal to time. Okay, so time is used to make what do you say? Time different. So time which you see here, it means that you are going to pivot at this time. So the column which you're going to pivot, you have to write in the columns is equal to time. It means that you want to pivot to this. You want to preserve the original, what do you say, original footprint of these columns. Columns is equal to time. It means that you want to pivot to this column time, and values is equal to reading. It means that in the pivoted columns that you have created, you have to fit in the values of readings. So now can you all see that I can see the similar structure what we have left in pd.melt. The similar structure that can we see here, the original structure. Can you all see this? The same thing here. Yes or no? So two things: pd.melt, pd.pivot. Two things: pd.pivot helps me to convert in a pivoting state. pd.melt pivot to unpivot. Unpivot to pivot, you use pivot table. Pivot to unpivot, you use pd.melt. As simple as that. Clear to everyone? Index means that these are the columns that you have to preserve. In this columns, you do not have to do anything. Columns equal to time, it means that you have to create a pivot on this. Values equal to reading, it means that you have to fill the values with respect to the readings on the columns time. Is everyone clear up to this part? Can I get a quick yes from all of you? Clear with the pivot and unpivot part in Python? Huh? Awesome, awesome. Great to hear that. So here I've written here as well. Pivot is the exact opposite of melt, and melt is the exact opposite of pivot. Okay. Melt opposite of pivot, pivot opposite of melt. As simple as that. Now, some certain times it might happen that your indexes might be disturbed. Certain times it might happen that your indexes is disturbed. What do you have to do? Simple thing, dot reset index. Okay. So what you can do? You can simply write, hey, data.melt this dot reset index. So what you see here is that you do not see time appearing here, date appearing here. You do not see date appearing here. You do not see date appearing here. But as soon as you write data dot reset, the whole thing dot reset index, you can see that now you can see the dates in the perfect format along with the, what do you see, along with the index column being appearing here. Clear to everyone? Is this clear? That anytime if you face any issues in the indexes part, you can simply write reset.index. That would do the work very fluently for you. Okay. So this thing you have to remember. Ah, data.melt head, you all know this. Okay. Now this is not important, not important, not important. Pivot table we have done. This we have done, not important. Next thing. What is bins? Bins. Binning. Have you heard of this term binning in SQL? Binnings. Bin. अच्छा ठीक है. Bins. So if I'll teach you about maths and stats, there's a very important concept with respect to the binning in histograms. Okay, in histograms we have basically a topic called as histograms. Okay, where we generally talk about bins. See, let's say we have name, we have marks. Okay, A, B, C, D, E, F, G. Okay, marks are 40, 60, 80, 60, 70, 70, 20, 30, 40. What I can do, I can, bins means buckets. Bins means buckets. So what I can do, I can play intelligently. How? I can create a column. And what I say that if marks are less than 50, treat it as average. Marks less than 30, treat it as poor. Okay, if else statement, if elif statement. Less than 50, average. Less than 30, poor. Greater than 70, good. And greater than 80, you can say excellent. So this 40 comes under the category of, let's say, uh, average, this good, excellent, good, good, poor, poor, average. Okay, something like this, average. So this is the new column that you created on the top of your data to create bins, to create buckets. This is what is called as binnings in Python, where with the simple numeric integers, with the simple numeric numbers, what you are going to create, you are going to create a category based on that which generalize. Okay, this is very important when you will do the analysis part on Python. You'll do that how important is binning in our data science, and binning is very important when you want to categorize your data into different types of buckets. Did everyone understand what is bucket? What is buckets and binning? How it is done? Simply segregating your data into different types of buckets. That is what is called as binning. Nothing else. As simple as that. So, can we use binnings to leverage other solutions? Yes. Let's see how. So you have this data like this, okay? Date, time, drug name, pressure, temperature. Okay, let's say we have calculated three different things: temperature average. We have calculated temperature average. We have calculated pressure average, something like this. Okay, temperature average and pressure average. We have created something like this. Now, how we have created this? You can refer to the above code. You will find it very simple. But let's say the data set looks something like this. I have done some modifications, and data set looks something like this. Now I have to create bins. How? What I've done? First, I would get the min and max value of temperature. While seeing the whole data, I got that min temperature was 8, max temperature was 58. Okay. Now, let's say you want to create 4 bins, okay, of 10 to 15 values each. It means that in each bin, you have to incorporate, let's say, 15 values or 10 values, not more than that. So, what we've done, you are creating different types of categories. Like the one which you created in students, the category which you have created here is low, medium, high, very high. And what we're trying to do here is that we know that the minimum temperature is 8 and maximum temperature is 58. So we are going to create a, what do you say? We are going to create, we had the minimum value is 8, maximum value is 58. Can I say that any value in the whole data would lie under this range? Yes or no? Any value of temperature would lie under this range. Can I say that? Yes or no? Any value would lie under this range, not more than that, not less than that. So can I say that I can create a categories on the top of this 8 and 58 number? Can I create a categories? Hey, if I know that marks, lowest marks is 0, greater marks is 100, I'm sure I will not create a category greater than 100. I will not create a category less than 0 because I know that the maximum cap and minimum cap is 0 and 100. Getting a point? So if I'm going to create a category, if I'm going to create a bins, I will not create a bin not greater than that and not less than that. Is the idea clear to everyone? Is that clear to everyone? Can you get a quick yes? That what is the idea? How we are going to proceed towards creating bins? We first going to find the min value. We are just going to find the max value, and then we are going to find, hey, data is greater than 8, data is less than 58. So our bins would be such that that would range between those regions or between those scenarios. So what I've done, let's for example, I have created 5 categories. Okay. So maybe the first bin I would be interested in, just giving example. Okay, what I've done here, just let me see the bins type. क्या था? हाँ, 5, 20, 35, 50, 60. So what we have done, 5, 10, 15, 25, 60. I guess this is the numbers, right? You can create any numbers. Okay, that is not an issue. That let me erase this numbers. 5, 20, 35, 50, 60. 35, 50, 60. So what are you trying to do? Hey, less than 5. Okay. So first bin between 20 and 5. This is first bin. Second bin 20 and 35. So any value which is between 20 and 35, second bin. Any value which is between 5 and 20, first bin. Any value which is between 35 and 50, third bin. Any value which is 50 and 60 between, fourth bin. And any value which is greater than 60, that is fifth bin. This is how I have created the bins. Any value between 520, first bin. Any value between 2035, second bin. Any value between what do you say, 3050, that is third bin. Any value between 5060, that is fourth bin. And any value between 60 greater, that is fifth bin. Is this clear to everyone? That how we are going to create bins? Are you finding the lecture boring, folks? Just let me know. Are you finding lecture boring? I finding it tough to understand. See, I'll make this lecture over by 5:30 or 5:40, not more than that. Okay, not more than that. So please be with me, because once I take a break and if I continue again, then that will lose the whole continuity, and I don't want. Okay, because this is a very important case study. It will make you understand some more things about pandas. Okay, just wait for 10 20 minutes more, and then I'll leave you. Not an issue. Okay. If you're feeling the same, let me know in that chat box so that I can give you a break. Not an issue for me as well. Okay. So I have thought of creating 5 bins where 520 first bin, 2035 second bin, 2035 50 for third bin, 50 60 fourth bin, and 60 plus fifth bin. Okay. So what I've done, I have created a list here. Temp points 5, 20, 35, 50, 60. This is how I have created bins. Okay. And how the categories are defined? I have defined low, medium, high, very high. This is the categories I've defined. Hey, अगर मेरी bin कोई 520 के बीच में लाई कर रही है, तो this is low, this is maybe high, this is very high, and this is medium, high, very high. So these are the categories that low, medium, high, very high. Okay, something like this categories I have. Okay. Now here, I guess why don't we have the fifth category? Let's see this. So what you have done? We have used a command called as pd.cut. What we have done? pd.cut. pd.cut is a command in Python that help us to create bins from the data that I have. It will try to rearrange the data in such a way that it will create bins on the top of it. So the command that help us to create bins in Python, very important interview question comes from here, that which command in Python helps me to create bins. So command simple that helps me to create bins is pd.cut. So we are going to write here data, so temperature. Okay, on the top of it, I want to create the bins. I've written that data frame here. It's a series, data, tidy, temperature, bins, temp point. It means that I want to create bins on the basis of this data. Okay, I have this range of data. Hey, 5, 20, 35, 50, 60. You can give any range, but it has to be between 8 and 58. Does not matter whether it is between, it could be 10, it could be 70 as well. Not an issue. You can create bins of any size, of any values you want. Okay. Then what you are trying to do? Labels is equal to temp labels. So Python is very understandable. It knows that how it has to allocate the data such that it will allocate the 4 labels. Okay, I have told you 5 labels, but Python, if you're given 4 labels, right? If you're given 4 labels, so Python will find a way that it will divide the data in such a way. It will divide the data in such a way that it will create 4 labels from this complete data. It will do it intelligently. Now, what is going inside Python? We'll not go into that part because that will take us to a different mathematics part. That how the bin size calculation is happening, how all these things are happening. We'll not go into those calculations. Just remember that pd.cut is a simple command that help us to create bins based on the labels that are given to us. Python perform this function very intelligently, where it create bins from the data that I have. So as soon as you're going to write bins is equal to temp points, and labels is equal to temp labels, that are labels that you have, low, medium, high, very high. So it is going to create you can see a temp cat. Okay, this is the new, what do you say, column, which is created by Python. And you see the bins being displayed for each and every row in your data frame. Is this clear to everyone? That how the labels are created and how the bins happening is created internally? It's doing something similar like this, right? That any value lying within this range, give this label. Any value which is lying in this range, give this label. Any value lying between this range, give this label. Any value lying between this range, give this label. Now, how the allocation is happening, that is a different thing. Maybe it would be happening in such a way that 5, 20, 35, what are the values? 5, 20, 35, 50, 60. Okay. Maybe it would be happening in such a way that if there are 4 categories, maybe they are defining, hey, 5 say 35, one category, 20s, what do you say, not like this, they may be dealing in this way, that 5 to 20 they may be giving one category, this second category, this third category, and more than 50, maybe fourth category. Okay. Maybe it could be 70 as well, 60 as well. So that could happen as this as well. Maybe it could be happening in this way as well. 5 to 35, one category, 30 50, second category, 50 60, third category, and 60 plus fourth category. That depends on Python that how it is going to treat it. Okay. That is all dependent on the internal calculation that how Python is going to perform in it internally. So that is how the calculation is going to is done internally, and you are going to get the labels in this way. Is this clear to everyone that how the labels are created with a simple concept of binning? Very, very, very important concept because this is very much utilized in the data analysis part. Clear to everyone? Let me know if it is clear to everyone or not. Clear? Achha, now we know that data tidy temp cat dot value underscore counts. What do we see here? We see that low temperature is with a 50 categories, with 50 count, medium 38, high 15, and very high 5. Okay. So this is how the numbers are represented for each and every category, which you can see in the data tidy temp can dot value underscore counts. You can see the same thing. Okay. Now, by default, creates interval of the form x comma y. It means that the way that I told you, it creates interval in the form of कि अगर ये uh, how it is going to create bins, it is going to create bins in this way by default. This is the default way, okay, that by how Python is creating bins. So it will create bins in this way. कि value greater than 5, okay, this term means equal to, greater than and less than equal to. So if I write x comma y, it means that value greater than 5 and value less than equal to 20. Maybe it is giving me one bin, value greater than 20 and value less than 35, less than equal to 35. Maybe second bin, value greater than 35 and value less than 50, third bin. Okay. Value greater than 50 and value less than, okay, value less than, what do you say? Maybe 70 or 60. This is fourth bin. This is how the bins are getting internally calculated. Okay. This is what it means by x comma y. X means do not include the x. I'm not including x in the equal to part. Y square bracket means I'm going to include the y, the left hand side as well, the right part, the right part. So value less than equal to 20, it means that I'm going to include this equal to sign, that I'm going to include this value under the binning part. So this is how the bins are calculated, and that's how you get your bins. Clear to everyone? Hmm. Now this is, we can teach you in the next class. That is not an issue. Okay. Now we are still left with some matplot. Okay, pandas part is mostly done now. Still left with some few things on the matplotlib Seaborn side. So probably we'll take one more lecture to complete this along with some Python concepts which are left. What you can do, I'll give you this Pfizer data frame. Okay, play around it, do all the analysis that I've told you, go through the notes, go through all the notes, see how I have done, why I have used all these things, and try to replicate in your systems. Okay. Then we can talk about something called as this matplotlib and cbond and see how it is useful to us. Okay. Along with this, we'll see that we have not seen how to handle this. Okay. I guess that will be taught in your machine learning classes. I guess that will discuss in the machine learning classes. Otherwise, it will be too much for you in Python. So feature engineering part along with this EDA, okay, the plots part, we will do in the next class along with some part of Python which is left, along with Python which is left. What is the homework for you is that you have to revisit the Pfizer dataset plus Netflix dataset, okay, that and IMDb dataset. Try this at your systems, try this at your end, and I'll give you a sheet of 50 MCQ questions on pandas. Solve that up. That is a homework from my side. Next class will be our last class on Python. So we'll try to complete that EDA part and the leftover Python part so that we can equally align with our course schedule. Any doubt, folks, up till this part? If you have any doubts, hit them in the chat box. The class is officially over. You can have your doubt sessions. The doubt session is open. If you have any doubts, I hope you have enjoyed today's session. Let me know if you have anything to say or anything to convey. What about project? Project we are doing in the class itself, Julie. Don't you think Pfizer, Netflix, McKinsey datasets, 5, 6, even Matplotlib and I'll give you 2 projects more. 7 to 8 projects. We have done enough projects, right? We started from NumPy, NPS score, Fitbit dataset, McKinsey dataset, Pfizer dataset, Netflix. Depends what is decided by CloudML, Ranit. I'm not sure on that part. Are case studies less in our course? Are you finding case studies less or are there enough? Are case studies less in our course? I don't think so. Anything which you want to convey? Thank you for today's class. I hope you all have enjoyed today's session. Okay, if you have anything to convey, put it in chat box. In ML, we can do. Okay, so much questions. Just give me a second. Let me visit each and see. Okay, the first doubt is, let me explain to everyone that is project and case study same. See, just give me a second. Yes. Huh. So what is the difference between a case study and a project? See, when I do a case study, right? When I do a case study, it means that is with respect to any specific topic. Like we have studied NumPy. NumPy में हमने study किया and we have done a case study on NPS. We've done a case study on Fitbit data. Then we have started with pandas. वहाँ पे हमने start किया एक loan application से start किया था. Then you have done the McKinsey data set. We have done this. Then you have done this IMDb data set. Then you have done this on this Pfizer data set. So these are not end-to-end projects, right? These are not end-to-end projects because end-to-end project starts from data cleaning and then it goes to the whole EDA part, okay, data pre-processing part, all plots, all correlations, all those things. Then you build a whole end-to-end project. Okay, case study is that you have studied a topic and on the top of that topic you are doing a kind of real world project. So project is a end-to-end. It is a end-to-end always. Now, second question comes, Tarang, can you mention this case study in your resume? Obviously, yes. Why not? Why you will not mention it? If you are keeping your resume simply blank, that will not going to help you. So either fill it with things that you have done, where you think that yeah, this case study has made the impact to the business because I am conveying some good insights that could be helpful for that business, or the business is getting benefited from my insights. Then it's definitely important that you mention those case studies. And once you have done with the end-to-end project, then you can remove those case studies because then you know that yeah, now I've done the whole end-to-end project. It's okay if you remove those case studies. That's not an issue. Okay, so I guess that question is clear in my mind that what is the difference between a case study and a project. In ML, we can do end-to-end project, right? Yes, we will do an end-to-end project. We will introduce at least 3 to 4 projects, which I have thought of. Let's see how it goes. Can you please talk to the cloud email teams about we need doubt sessions where from sessions till now just taking chats on not getting proper replies, so we need a proper doubt solving sessions from cloud email. Completely agree to that part, and I can convey the session to you, but our idea is simple here. See, my idea is that clear the doubts instantly. Why? Because sometimes if you this is although this is a Zoom session, but sometimes the chat goes so fast that we forget to take the doubts up. So my idea is to take the clear the doubts instantly in the class. Having said that, there could be times when you would face issues in the what do you say assignments part, and you might be facing doubts. And that's why I ask every time that have you completed the case study, have you completed the assignments, to get an idea. So yeah, we can keep a doubt session where you can address all your doubts, where you can take all your queries. But our prior preference is, at least in my class, what I say that let's clear it out instantly in the class itself, or we can spare some time in the middle during the breaks or at the end. That will resolve our doubts instantly, so that we are clear that yeah, this is a doubt I faced and the instructor cleared this up. So we can have that way as well. I would say that that way is more beneficial for you as well and for us as well, because we can collate all the doubts in one class itself for that perspective, for that respect, what do you say, for that for that perspective, for that respective topic, right? So that is even helpful. So yeah, I can talk about that as well. Just give me a second. Let me provide the feedback link, and then we can have the more doubts or anything. Slicing 10 row and 2 column is using log is not possible. Why? See, log, as I told you, log always considers the implicit things. When you say about implicit things, it means that there, you play around with the, not with the Python predefined indices, where there you play with the normal row numbers. There you play with the row numbers. Now, when we are playing with the row numbers, it is important to note that we can slice, but yeah, let's say if you want to slice the last column, if you want to get the last column, right? So instead of writing in this way, colon minus one, okay, colon minus one. Now this we cannot do through lock, while it is possible through ilog, because ilog considers the Python syntax, it considers the Python indices. While if I see the log syntax, log follow the indices of the row numbers. If you want to address the first row, you can simply write, hey, let's say marks dot log to see one. It means that it will fetch you the first row. So that is the primer difference, that while lock is not able to fetch from the slicing is not possible from the lock side for the last row, or for the predefined columns. For lock, you have to specifically define that which column or which row you have to fetch it. I hope you got your answer, Shama. That why lock is not, because lock does not follow the Python syntax format. It follows the rows number to slice the rows, row number to slice the rows. हाँ जी. What is expected from a fresher in Python interview? Should we focus on practicing thoroughly through NumPy and Pandas, as they seem to be the most important parts of in Python? Things important are NumPy, Pandas, list, uh, sometimes questions on list, functions, matplotlib, and cmon. More than enough. Mostly questions from this part, NumPy. This is the icebreaker thing. Cool. Z. Sir, can you help me to make resume? Surely we would be having a class on how to optimize your resume as well as LinkedIn profiles in the coming sessions. So probably that would be helpful for you, Sulmuli. Okay. Anything else with respect to the class, folks, which you want to highlight, or which you want to focus? I hope you have enjoyed today's class. You have learned a lot. Anything else? In interview, do we not to solve the case studies? No, we do not have to solve the case studies. We simply have to Like if the questions on case studies are asked, they are basically asked that how did you do this case study? What are the challenges that you faced? How did you overcome those challenges? Questions like these are generally asked when it is with respect to case studies. Huh. If you've used a function, interview would ask you, hey, how would you use this pd.cut in this data? How you will use pd.melt in this data? How much? So questions like those would be asked. How much more month will our batch complete? It depends on what are things that you have completed. I guess maths and stats 1 month, ML 1.5 month, and okay, Ashwini, I guess I can get an idea of what maths and stats I'm teaching. So I guess around 4 to 5 classes we have taken to complete this maths and stats part, and ML part. I guess it will take around 7 to 8 classes, maybe 2 months as well. Which platform is better for job hunting? As in LinkedIn, there are many fake job postings. Try for Naukri, Naukri.com. Naukri is the best. Naukri referral. LinkedIn is also best, but LinkedIn is only, I would say, try for referrals. Try for referrals on LinkedIn. Try for referrals on LinkedIn. If you want to generally apply for job postings, refer to Naukri or to the official career website of that company. Two things. Does while and for loops often used in data analyst roles? I would say that they are used because let's say you want to automate, you want to make the things work for the complete data. In that case, you want to iterate through each and every row. So yeah, while and for loops are quite used in the roles. Said okay. See, practice, practice, practice. Pandas is all about practice. Practice about NumPy. Practice about pandas. See how the syntax is working. Why ascending is equal to false is reduced. Why access equal to 0 is used. Why access equal to 1 is used. Why in place equal to true is used. Try these all things. Ask questions from yourself that why this is used, why this is not used. Try from the syntax part. Try from the case studies part. Okay, do all those things, and that will do the work. Thank you. Thank you, everyone. I hope you all have enjoyed today's session and found today's session helpful. And the next class would be a last class on Python. So please come up prepared with all the case studies part. If you have any doubts, you can ask in the next class. We can discuss them thoroughly. Okay. And let me know, and do let me know if you have any doubts which are left unanswered by me. I'll surely try to answer them up in the next class. That's for sure. Great, great, great. Awesome. Thank you, thank you, thank you, everyone. Means a lot. Thank you, everyone. Means a lot. Thank you, thank you. Last 1 minute, folks. Thank you, everyone. Thank you. Means a lot. Thank you. Thank you. Thank you. Thank you. Means a lot. Thank you. Thank you, everyone. Sure, 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 Samir. We'll definitely arrange a doubt session for all of you so that you can clear your doubts. Okay. Okay. That's all from my side. Take care and have a good day. Thank you. Bye. 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 Thank you.